Hello, Flat Earth researchers, debaters and debunkers. This is a demonstration of an observation that anyone can make, and it is to show that we know when a camera is level because the horizon is always at eye level, no matter how high we go above the Earth's surface. And this simple fact totally disproves the globe-Earth theory, because as we know, the idea that the horizon is a certain distance away from the observer, depending on their height, is simply how the globe-Earth model must be when we are given it with a side-on orthographic view using geometry to create a tangent line of sight from an observer into a bulge of curvature on the Earth. But this is simply perspective. The very fact that when we look straight ahead, the surface and the sky appear to meet in the center of our field of view, what is called eye level. And this happens at any height. At sea level, we can see, if we take this railing and put it in the center of the camera's field of view, and we have the camera pointing straight ahead, then the horizon in the distance is also at the same level. And that is eye level. That's how we know that things in front of us are lined up and that we are looking at them from a straightforward, level point of view. This is simply how it works. And it works at any height, because it's an optical phenomenon. Whereas with the globe, we are given this idea that the horizon is curvature, and it is entirely based on mathematics that relies on the Earth's surface curving away from us or bulging up in front of us. So we have arguments about this apparent drop in the horizon. But again, it is only when a camera or an observer is looking straight ahead and they are level that the horizon is at that person's or observer's eye level. And so if we want to make sure that anything between the observer and the horizon is exactly at the observer's eye level, and therefore ensure that we are looking straight ahead, then that's when everything lines up. That is eye level. And so when we look straight ahead and we raise or lower our height in relation to whatever's in between ourselves and the horizon, then we will of course see a difference in the relative height of whatever's in between the observer and the horizon, but the horizon always remains at the observer's eye level. So using something in between, such as water or a line on a heads-up display in an aircraft, is not eye level. The eye level is in the eye of the observer or the camera itself. And we can see that when we move up and down at any height, the horizon in the distance is at our eye level, simply because it is flat. And that is how we see flat surfaces. So sometimes people will make an observation similar to what we have shown here with the water bottle in between the observer and the horizon in the distance. And of course it's very, very close. So we very quickly get this difference with the slightest movement up or down or the slightest tilt towards the object immediately in front of us, or the water or whatever is demonstrating level immediately in front of us, and the distant horizon. So any slight deviation from true level, true eye level, will result in a horizon line that is not in line with the object in between us and the horizon. So here we can see this bottle at about 30,000 feet, 35,000 feet, on an aircraft that is slightly pitched up as it flies what is called straight and level flight. So it is going in a level, parallel direction from whence it came. And although it's pitched up, it has to do so just to maintain the lift with the less dense air. This is simply how aircraft cruise. But they are only a few degrees pitched a few degrees up from the level that they were when they took off, and that has not changed. Level does not magically change from the original level as we imagine that we make our way around a globe. This is simply an imaginary scenario to go with an imaginary model by saying that down is always towards the center of a spherical Earth, and therefore level is anywhere that's perpendicular to that. But no, what we have with flying and straight and level flight, and as is demonstrated by water maintaining its level, is that an aircraft flies above a flat plane Earth, and it does so in straight and level flight. That is, the only difference is the height above the level that it started. There is never ever any change in the angle of level from the original level. So you can fly anywhere in the world, and you might be at a higher or lower altitude from where you began the journey, but you will never ever be at a different angle physically. And the only argument against this is, well, first of all, we have this alleged horizon drop, which, as we can see from this footage, is very, very easy to create or take a snapshot at the right time when the camera is not level or it is not in line with the water level in front of it, as well as the horizon beyond it. But moving the camera into a position of true level keeps the horizon at our eye level, and it puts whatever is demonstrating level to us between the horizon and the camera in the center of the camera's field of view, and it will be level. So again, must emphasize that this demonstration here was not done with any high-level degree of accuracy. It was simply a case of grabbing a bottle of water and holding the camera as level as I could. But we can see that there are points when everything lines up, and that is going to be eye level. That is simply the nature of any observation that we make. So there really are no arguments based on the real-life observations that we can make at any height. This is an absolutely true statement that the horizon is always at eye level. Again, eye level being the observer, whether it's a camera or a human eye or a laser or whatever it might be, pointing straight ahead on a level that's parallel to the original level on the ground. It's simply a case of going up in the air and maintaining that direction of the line of sight, the horizontal direction of line of sight that's parallel to a flat surface, and this is what we will always see. But of course, horizons as we get higher up become less clearly defined, because essentially what comprises the surface at this altitude is clouds. So it's all going to just fade into obscurity anyway. There's not going to be a clearly defined horizon line in the same way that we see when we are at sea level or just above it. And we can see a much more clearly defined line because we are seeing the surface. If the distance that we can see is not obstructed by any other conditions. So this is why people will argue and obfuscate, create confusion, or even be deceptive or misleading in what is referred to as eye level, and then by taking snapshots at a time when things don't quite line up with fractions of difference in the inclination or declination of the camera from horizontal, or a fraction of distance above or below the level of the object between the camera or the observer and the horizon. So again, this is an observation that anybody can make anywhere. This is simply a fact of life. And this is why it quickly becomes apparent, if we take this observation as a fact, that any ideas about the distances we can see to the horizon and the angle at which we must be looking at some kind of bulge or drop in the horizon are just arguments that have no basis in reality, and they are only present as arguments because of the way the globe Earth is illustrated with geometry from an orthographic view, representing what the observer is supposed to see or supposed to be doing, their angle. And of course we are given excuses about the scale of the Earth, making it always appear flat. So this is just one simple observation that must be considered and can be done by anyone, but taken into account along with all the other compartmentalized explanations that go with trying to define the globe Earth as a spinning ball going around the sun, basically explain the heliocentric model, because we're always told to imagine the Earth from somewhere in space. But when we compare that idea with the observations that we make in reality and the way we make the observations, the science behind making an eye-level observation, the only way you can make an eye-level observation is to line up the camera with a level object and the horizon. That is when we know that we are pointing in a direction that is eye level. So, hope whoever wants to try and prove this for themselves will go and do so. Thank you very much.